Good morning, friends. Let's start studying the space forces today. We have to resolve all these space forces into three different components, and there are certain applications of these resolutions. I'll share certain screens with you and make you understand what are the different forces. So first of all, I have drawn one figure over here. We are having the three axes, x-axis, y-axis and z-axis over here. This force OA, the force OA, it is representing the force F over here. The component of this force with x-axis is Fx. The component of this force F with y-axis is Fy, and the component of this force with z-axis is Fz over here. Now the next point is that any force I can represent in the form of F is equal to Fxi plus Fyj plus Fzk, where this Fx can be written as F cos theta x, Fy is equal to F cos theta y, and Fz is equal to F cos theta z. What we have already studied in 12th standard is the angle made by any line with x-axis, y-axis and z-axis. It makes certain sense to us. And what is that sense? The cos of those three angles made by the line with the respective coordinate axis, they are representing the direction cosines of the line. And what we have named them as L as cos theta x, M as cos theta y, and N as cos theta z. What we have already studied over here is L square plus M square plus N square is equal to 1, or other way around, cos square theta x plus cos square theta y plus cos square theta z. That value, this value, that is equal to 1. This we have already studied. Now the next part, what are the use of this? What is the use of this concept? We have to find out the components of this force when we have been provided the orientation of the force with respect to the given planes, or with respect to the given axis, you can say. The force, let's say we have drawn over here, let's say this particular force F, which is along OA, is making certain angle theta y with the axis y, and this projection of that F on XOZ plane is, let's say, OC. This is, that projection is making angle alpha with x-axis. That has been given to us. Over here, I can find out the y component of this particular force is with Fy is equal to F cos theta y. Now, this FOC will be, naturally, it will be F sin theta y. This we have already studied how to resolve the force along with x-axis and y-axis. Whenever we have studied the two-dimensional resolution of the forces, in that case we have studied that one is F cos theta and another one is the F sin theta. On the similar lines, this has been resolved. The next point is this FOC now, which is making angle alpha with x-axis. So naturally, whenever I want to find out this component, I say Fx component, what it will be? It will be FOC cos of alpha. We have already found out the value of FOC is equal to F sin theta y. Again, if I want to find out the Z component of FOC, it will be what? FOC into sin alpha. It has been already written over here. It has been shown in this particular, whatever I was talking, it has been shown in this diagram. Next is, so finally, we want to write down the X component of the force initially given, and the Y component and the Z component. That is, X component is FOC cos alpha, or FOC we have already written, that is F sin theta y. So this total Fx, Fy and Fz has been listed over here. You can go all these three. Now the next point over here is we have to go for the moment of the force about any point. So moment of the force is the vector product of R and F. R is the unit, R is the vector representation or the position vector of that particular point of application, and F is the force vector for which we want to find out the moment. So MO is equal to R into F sin theta, or MO is equal to R cross F, that already we have seen. The next point are this MO or R cross F, it can be represented in form of the matrix, that is R cross F is equal to ijk Rx Ry Rz. This Rx Ry Rz, they are representing the x, y and z component of the vector R, and fx, fy, fz, they are representing the x, y, z component of the force given. Now next point over here is what is the direction of the movement, of which uses over here the right hand of, whenever we want to find out the direction of the moment, we have to use the right hand, and which is the rule. So we have to hold the axis of at which we want to find out the moment in our right hand. If these curled fingers, they are representing the direction of the force. We have to go for the curled fingers as the direction of the force. Then this thumb will represent the direction of movement. Now here we have to find out this moment of force analytically. What is the analytical value of that? So if we have to consider a force, let's say F is equal to Fxi plus Fyz plus Fzk passing through these 2 points P and Q, and we have to find out the moment of this force with respect to the point C, that is x3, y3 and z3. So finally that value or that expression is mc is equal to what? ijk x1 minus x3, y1 minus y3, z1 minus z3, fx, fy, fz. This determinant we have to solve to find out mc, or the other way around is ijk x2 minus x3, y2 minus y3, z2 minus z3 and so on. So these are the two formulas that we have to use to find out the analytical value of the moment of the force about any point which has been given to us. The next point is what is the moment of force about a line we have to find out. Let's say F is equal to again Fxi plus Fy j plus Fzk, and the line is OL. OL is the line. I'll show you in the figure. This is the line about which we want to find out the moment of this force F. Now this, look at this. This MOL is equal to what? Direct unit vector along the direction of this OL, the unit vector along the direction of this OL, and it is dot MO, it is dot product. MO is what? Moment of the force about the point O, that is R cross F, that already we have studied. And finally MOL is equal to what? EX, EY, EZ. EX, EY, EZ, what is this EX, EY, EZ? These are the components of the unit vectors of the line L, that is Ex, Ey, Ez, X, Y, Z and Fx, Fy, Fz. This is the analytical part of the moment of the force. And moment of the force about the line which is not passing through the origin, if we want to find it out. So this is what the expression for that. Here the line I have shown is this is the force, and R, this is the R in between them. So this expression is what? The moment of the force about the line BL, where the B is the point on the line having the coordinates x2, y2, z2, and moment at BL is equal to lambda x, lambda y, lambda z, and this is the expression for that. You just write it down. Finally, the Bergman's theorem that already we have studied for the two-dimensional forces, that is summation of the moments of the forces about a particular point is the summation of all the resultant. Summation of the resultant is equal to summation of the all the forces about that same point that we have already studied. And in case of space equilibrium, what is the condition? It is summation fx is equal to 0, summation fy 0, summation fz 0, and summation m is equal to 0. Now let's go to a simple example. We are going to study only 3 examples today, the simple examples, how to resolve the component or how to find out the component of any force which has been given to us. In this particular example, what has been given as is the force, the magnitude of the force is 300 Newton, and the angle made by that force with z axis, look at the figure carefully, angle made by that force with z axis is 45 degrees, and angle made by that force with y axis is, it has been given to us as 60 degrees. So what we know over here is cos square theta x plus cos square theta y plus cos square theta z is equal to 1, or L square plus M square plus N square is equal to 1. That we know already. What we have been provided are the two angles, and what we don't know is the angle made by that line with the x-axis. That we don't know, that we will be finding out. So I kept that values over here. Theta y is 60 degrees over here. Look at this. Theta z is equal to 45 degrees over here, and we can find out the theta x as 0.5 or cos theta x as 0.5. That will give me theta x is equal to either 60 degrees or 120 degrees. Now, but what has happened, this force, it has been given to us in the direction of y, x and plus z. Look at the figure. It is plus x he has given, plus y he has given, and plus z he has given. So, and the force is directed towards all the what we call it as the positive octet of the space. So I have to choose, or we have to choose the angle theta x as 60 degrees over here. So again, the unit vector along the direction of that line will be what? Cos 60 degrees I, cos 60 degrees j, cos 45 degrees k. And we have to find out the vector representation of the force F, which is having magnitude as 300 degrees, and unit vector is what we have already written, cos 60 degrees I, cos 60 degrees j, cos 45 degrees k. So final value is this. You can calculate all these values on your own, and finally which gives me fx is equal to 150 newton, fy is equal to 150 newton, and fz is equal to 212.13 newton. And this, just check this, all these values, and check your answers. Now the next question or next problem is, we have to represent this force F in a Cartesian vector. What we have been provided is the angle between the projection of this vector on xy plane is this, the projection of this vector F, and this angle has been provided as 30 degrees, or what has been given to us is the angle between the force F and the plane xy is equal to 30 degrees, and the angle between the projection and the x-axis is 60. That has been given to us. So how to solve this problem? Look at this. I have redrawn the figure. This is 10 kilonewton force has been given to us. So F is equal to what? Again, I can find out F is equal to F1 over here. So let's call it as F1. So F1 is equal to F cos 30. So it will be 10 cos 30 kilonewton. So its value is 8.66. Now I can find out the components of two components of F1. I know the angle between x-axis and this F1 is 60 degrees. So Fx is equal to, directly I can write F1 cos 60. Fy I can directly write as Fy sin 60. And what we know is this angle between the force and the z-axis, directly we know. So that is equal to F sin 30. Now look at this. Fx is F1 cos 60. Fy is equal to F1 sin 60. Whereas Fz is equal to F sin 60. That is the difference between these two components. It's these two F1 we already found out with use of this figure. Just try to understand the difference between these three. Okay. And one more last point is this expression. Only same question has been repeated over here. Only the angle between the z-axis has been given to us, and the angle between the projection of the vector and the x-axis has been given to us as 40 degrees. So you have to solve this problem with use of the concepts what we have already studied, with use of the concepts what already we have studied in the previous problems, and just check your answers with the answers given over here. If you have any doubt, about this complete explanations, you can contact on these two numbers, and you can write your feedback with on WhatsApp also, or you can directly contact with us. You can write down the expressions, you can write down your feedbacks, you can write down your queries if you have, and if you want to, let's say, solve any of the new problem, then you can also tell us about that problem. You have to write down the complete thing, or you have to give the complete data so that we can solve it and you can make you understand. Thank you once again.